our podcast. I will be explain about memory hierarchy and cache.
Hi Nadia, so I will continue with parallel processing and how it relates to system performance.
Let's start with memory hierarchy. Memory hierarchy organizes memory from the fastest and smallest to the slowest and largest. At the top are registers. They are directly connected to the CPU and extremely fast, but their storage capacity is very limited.
So the CPU needs something else to avoid slowing down, right?
Exactly. That's where cache memory comes in. Cache is small, very fast, and located between the CPU and main memory. Cache store frequently use data so the CPU can access it quickly without always going to RAM. Cache is divided into L1, L2, and L3, with L1 being the fastest.
And below cache is main memory.
Yes, main memory or RAM store active program and data. It has largest capacity but slower speed compared to cache, and it's volatile. For long-term storage, we use secondary storage like HDDs, SSDs, and optical drive, which are non-volatile.
Now let's move on to parallel processing. Parallel processing allows multiple tasks to be executed at the same time using more than one processor. In a multiple processor organization, large tasks are divided into smaller parts and distributed among processors, improving speed and efficiency.
That must put more pressure on memory access, right?
Exactly. That's why an efficient memory hierarchy and cache system are essential, especially in symmetric multiprocessing or SMP. In SMP system, all processors are equal. They share the same main memory and input or output devices and run under one operating system. Multiprogramming use one CPU that switch between programs, giving the illusion of parallelism. Multiprocessing, however, use two or more CPUs or cores, allowing true parallel execution.
So without fast cache and memory, processor would waste time waiting for data.
That's right. But even with many processors, performance has limits. According to Amdahl's law, the speed up from parallel processing is limited by the sequential part of a program.
Meaning faster memory help, but the program design still matter. In summary, memory hierarchy and cache reduce data access time,
While parallel processing increase execution speed by using multiple processors. Together, they improve overall system performance. Thank you for listening. Bye.